All right, so this is my talk about how Kubernetes was the secret sauce in our globally distributed team's transition to microservices. The title's a bit verbose. Pretty much it's how Buffer started its transition to Kubernetes. We're a small shop, and I hope that this has a little bit of, sure it has some overlap with the previous talk, but also has a little bit of story for a pretty small team that is leveraging Kubernetes to run containers in production without being experts in Kubernetes. So yeah, to start off, just a little outline of what we're going to cover. Hoping to give you a little bit of overview of what we've been up to for the last few months, how Kubernetes has been instrumental in helping our remote team, and I'll walk you through the before infrastructure of what we had and still have in our legacy infrastructure and some of our challenges that we had. And I'll talk a little bit about our move to Kubernetes and some things that we learned along the way. Lastly, I'll share where we're at today and what we're planning to do next. So yeah, getting started, just a little break about me. I'm the architect of Buffer. And Buffer, if you don't know, if you haven't heard of us, we are a software company that builds a social media management tool that allows you to schedule and collaborate on social media posts across all the different social networks and on hundreds of different profiles, as well as pull in analytics and see how well you're doing on that. This is for publishers and marketers and whatnot. So that's what we build, and I like to call myself I'm a bit of a generalist. I'm no expert, but I do like to say that I'm an ops-minded, full-stack product engineer, which is a mouthful, but it's kind of been the story of jumping around since I got with Buffer. So yeah, since the beginning of the summer, we've kind of been wanting to push towards the service-oriented architecture, and I've been leading that and heading up that project, and Kubernetes has been really instrumental for us. Afterwards, if you'd like to connect with me, shoot me an email or talk to me afterwards. But I'd love to hear what you think, or feedback, or suggestions, or whatnot. So yeah, this is a little diagram showing off, what our infrastructure was in the middle of this year. Most of it is still true. We haven't moved too much with the existing app. But yeah, this is just a mile-high view. Really, all of our different server environments. We're on AWS. We're using Elastic Beanstalk to just deploy copies in these different environments. We have one massive repo that everyone's is deploying on, and that repo is deployed to every instance. So it's pretty tightly coupled, and just different environments execute different parts of our big repo. And with Beanstalk, we were having weird kind of scaling stuff where we not able to fine tune our worker instances and different processes that we were running on each of our servers. So this is a little bit about the Buffer team. We are a team of 80 fully working remote, scattered around the world. We pretty much are, someone's online 24 hours a day. If you can see here, these are our team structured by time zone. And we kind of have not everyone in each one of these areas is in that city. That's just kind of, as you see, there's 58 cities that we have. So it's, we're kind of scattered. So it's a little bit of a atypical kind of company, but it's getting more popular as you see these days. So our engineering team is roughly 25 of the people that you see here. We have 15 people regularly committing and deploying code to that massive repo that's getting shipped everywhere. We have 3 kind of DevOps type engineers, 2 of which that mostly reside in Asia, in Taipei and Sri Lanka, and 1 that kind of floats around between Beijing and France and wherever he chooses to be. So yeah, there's many positives on being remote. There's a lot of cool things, but I think it's also key from what I'm talking about is to highlight some of the challenges with a remote team. It's really you can, but it's difficult to call a single meeting and really get everyone on the same page immediately. It's kind of hard to just grab all the engineering team and round it up and get a lunch together and just roll something out or start a new agenda. Also without the ability to tap someone on the shoulder for a quick question on something, it can be harder pushing through technologies on the team. We basically we have Yeah, it's difficult because you don't have direct access to the people who might be, the in-house expert on a technology. So you might have to wait 4 hours until they wake up. So there's different challenges. We have to really focus on being asynchronous, and all our developers need to be very independent as much as they can. So there's also a thing, we need to give some empathy to our developers, because they might work in a place like Sri Lanka or somewhere on Eastern Europe, or somewhere in the Pacific that they don't have the overlap with that and the access that all engineers do. So it's we need to make sure we take all those things into consideration whenever we do anything at Buffer. So these are some of our challenges, like I talked about. Buffer, kind of had that classic lean startup kind of mentality. Started about 5 years ago, and just kind of kept tacking things on, kept shipping things, trying to grow. Growth was number one, and kind of just couldn't pull our foot off the gas to re-architect the app and pay down some technical debt. So that struggles, when you get larger, and so it was something we had to address. Our engineering culture, something we take pride in, is we have this saying of, you ship code the minute that it's better than what's on production. So we just, as our culture and our DNA, we ship all day long. So that's, we're deploying things 24 hours a day, and as you can tell, we're all shipping to the same environments with the same code. There can be a lot of conflicts. Merges are a little bit messy sometimes, and with our tightly coupled application, this is, there was updated changes 4 hours earlier, or a library someone might have not known about 5 hours later and deployed and broke something. We've gotten better at averting some of those things, but still it's a bit of a bottleneck, especially as we've grown our team over the last couple of years, especially. 2 years ago we were under 20, so we've had a lot more engineers, and more deploys. We're making bottleneck. People are queuing up for deploys, and we don't have the sense of we have more atomic deploys rather than shipping a bunch of PRs all in the same deploys. So we also kind of, the way that we grew and being a remote team, we had limited senior people who were there in the early days who know how everything works. And I think kind of tying into the next point, we had no logging, which made it even harder for anyone to really figure out what was going on with their application. There's a lot of just system intuition of senior people on the team. So you can see these are issues, and we got by somehow without these. And we're a very transparent company, and we're doing $12 million a year in revenue annually, and that might be small potatoes for a lot of people, but for us it's pretty cool. And I don't regret the decisions that were made. These are just kind of some of the challenges that we have today. So I don't know if anyone knows the movie Roadhouse with Patrick Swayze from 1989. I like to compare our situation to that. If you haven't seen the movie or don't know the premise, I'll try to give a quick rundown because I think it's important. So basically the movie takes place in a small southern town at this bar called the Double Deuce, where every night things are just kind of a little out of control. There are fights, bouncers can't control people, there are broken bottles everywhere, people are throwing things at the band, and it's the bar is in a bad way, and it needed to be helped out. So that's where Patrick Swayze comes in. He's this, and this I'm pulling this straight from Google, he is a hotshot, PhD educated bouncer who knows exactly how to clean things up. So we needed our PhD educated bouncer, basically. I'm not saying that our infrastructure is as bad as Roadhouse, but regardless, we needed something to happen. What we needed, we needed to look for our own Swayze. We wanted to make major leaps. We didn't just want to make incremental changes and do things. We wanted to just completely 10 times what we had. And we needed a really way to how do we escape the monolith? We talked about it for a year and a half, and it was difficult. We just didn't have experience on the team. We wanted to be able to create and ship new services really quick. To address our scaling challenges with our previous infrastructure, we wanted fine-grained control over all our services, rather than scaling these big hunky EC2 instances with Elastic Beanstalk. So we also wanted to stay true to the team culture. We wanted to deploy constantly, and we wanted people to just deploy right from Slack the second that they wanted to, and be able to coordinate their deploys right there. So we really, really needed logging too. That was something that was incredible, and we majorly struggled with this in the past, so we figured, we needed to make this as easy as possible for all our developers to do. It may sound elementary for a lot of people, but we had a culture where we weren't logging, so we needed to change that dramatically and really make it simple for people to kind of get going with that and log good actionable logs. So yeah, and I think lastly, we'd been using Docker in development for about 6 months to a year, depending on what projects you were working on. But we had very little experience running containers in production. We were kind of rookies at containers, if you like to say. So we were just kind of focused on shipping things and getting our single page app working and whatnot, and just delivering value to the customer as soon as possible. So yeah, so after this, how are we gonna address these challenges? We wanted a lot. We evaluated a handful of solutions, and I'm sure that you guessed that we landed on Kubernetes. It's our Tai Chi practicing Patrick Swayze. That had all the tools that we needed to get set up and to get everything straight. It also gave us a solid foundation to choose the right solution for each challenge, really, for us. At this point, either this Roadhouse reference is making sense a lot, or it is completely obscure, and you're just happy that I'm talking about Kubernetes now. So with we kind of chose on Kubernetes, and then we decided, what are we going to do now? How are we going to make this thing successful? We didn't want to spend a lot of time and create something and then just have it sit there and people were still stuck in the old way and never migrated anything out of our old system. We needed to really demonstrate the value, and make it really easy for product engineers who had no experience with this stuff to move their services out. A few of us on the team knew the upside of what we were doing, but we really wanted this to be successful, and we wanted to figure out what to build once we had everything in place. We needed to show some examples. What would be our guinea pig for this for our Kubernetes journey, kind of. Maybe most importantly, we had to just educate the team. Everyone just really needed to know how to use all these things, and how to jump in without having to read the docs and learn all the mistakes that you learn when you get into it for the first time. So we divided a plan. Our high level was pretty easy. We split it up. It was 4 engineers. The 3 DevOps guys that I mentioned and myself kind of headed up this thing and said, we just need to make this successful. We started, I guess, about the middle of the summer or so. Each one of us owned one of these areas, and collaborated every day. And we were having meetings in the morning and night, so I could catch them in Asia or Europe, wherever they were, and really it was a quick iteration cycle. It was really great to feel the energy of what we were doing there, constantly, every day, making progress in each area. So I'll walk through a little bit of the plan and how we kind of executed on some of these things, and what we chose. So yeah, first, I guess one of the most important is getting cluster up. We need to get in the weeds with Kubernetes. We had little experience running containers in production, so no experience with Kubernetes. We weren't, core contributors or anything, so we kind of just thought hey, let's take this off-the-shelf solution and see if we can make this work. So, we thought, we didn't really think anything of it and said, yeah, why not? Yeah, sure, we can do this thing. So, not only just standing up our first cluster was important, but we had to get some other things figured out early on. We stood up a lot of clusters, just tore them down, did a lot of testing, figured out how it worked internally, tried to break some things. We did an early migration from 1.2 to 1.3, just basically spinning up another cluster, migrating services, trying to write some scripts around that, and some early learning with some of these things, how it could work. We ended up using some service accounts for just quick and dirty access, but everyone has full access to every namespace. We have for different teams in the company, kind of pretty loose right now. And it's not as secure as we like, but you know what? It's allowing us to share knowledge across namespaces and being able to pop into other people's areas and just see oh, hey, you're doing this. This is very interesting, and kind of share knowledge throughout the team pretty quickly and be able to help people out. So yeah, we kind of stored everything in a private Git server with a lot of our resource YAML files, and And it was okay. It got us at least moving. It was not ideal. It was not the perfect way that we needed to do things, but it got us to moving and starting to use Kubernetes and seeing things light up. So these choices that we've made for these, I want to highlight, these aren't recommendations per se, but these are things that we chose and how we balanced our time, our resources, the cost to maintain these things. They were the right call for Buffer, and everyone has different needs and constraints. So take these with a grain of salt, and do whatever is best for your team, really. This also is is still an area that we're pretty challenged with. I think you see a lot of those vendors out there, and they're have things about standing up cluster kind of just provisioning is still something that we do need to focus on a lot more. So, and I think with Kubernetes, we're standing on the shoulders of giants, as you'd say, but we don't really know the giant too well. We don't know the inner workings too much. So we're constantly digging in and finding new things and getting in and reading the source and understanding how things work. So it's been a fun journey, but this is the first step, kind of pushing us forward. We also wanted deploys to go out really fast. So one of the things we also did was really fond of deploying with bots right in Slack. So /deploy, whatever your service is, should be as simple as you really need to get it out there. We wanted really just super smooth for everyone to kind of handle and be able to approach. So we stitched a few things together. We basically figured out our flow, threw it up on Jenkins, worked backwards from there. We originally tried to use an AWS Lambda function to handle our Slack command, but that was a little bit not as flexible as we'd like, and kind of had some downsides. So we ended up just rolling our own bot that we're hosting on Kubernetes itself, which was super, super great, and has a little dashboard that developers can kind of insert their Git repo and what Docker file to build and where to ship it to. And it's as easy as that. It shows up right away. So we, our bot itself is hosted on Kubernetes. Like I said, it handles its own deploys, and our deploys right now are out in 45 to 90 seconds, which is awesome. Compared with our legacy app, still is hovering around 3 to 4 minutes, and at times it struggled and was out at like 5. So we wanted to move faster. We're deploying all the time, so this is already having an impact on getting our new services and getting bug fixes and improvements out like so much faster. This has really helped. All the developers have started to take advantage of this. Have really, really appreciated it. And as a bonus, we kind of added a rollback command. And I'll talk about that in a second. Just a little easy way to roll back your recent deploy. We're open to add canary deployments to this too, to make it really easy for developers and abstract them away from the kubectl, but we'll figure that out next year. I think that's something our team will love. This is just a simple little show of like what our deploy bot looks like with some of the services that we can deploy at any given time. It's really fun, and then if something goes wrong, you just deploy rollback, my service, and it just undoes everything using rollout undo. So it's really built a lot of confidence into our team, especially non-developers, designers, or people editing static pages, just content on our jobs website or something, as well as like our data analysts. They've extremely they've improved their iteration cycle rapidly. They used to wait for an engineer to get on to deploy their updated script that's generating some of our calculations on user behavior or finances, and now they're just kind of shipping their new scripts constantly. They've just absolutely loved it, and there's so much more that we can do for them, which is it's opening up a lot of doors for even just our data team, who didn't think that they, at the beginning of this, would even take advantage of it too much. So it's been awesome, and one of the things that we kind of, after deploys, was going towards looking at logging. As you saw, this was a real pain point for us. Really needed to get this part right, and we started off, we knew we wanted to get our logs in Elasticsearch. We're really fond of that, just pulling things out with Kibana. We experimented with a few different ways to do this. Wanted to really have just a couple weeks worth of logs on Elasticsearch, one location for all our apps, on all our services, and then maybe some long-term storage too. So we also wanted to standardize our logging format a little bit, so you could search on something, a related ID or something like that, a user ID, across all your different logs, across all your different applications. You could see user behavior and what was happening to their data. This has been great. We had to, standardize and really think about some of these things. Key was getting some of this stuff out in front. So when developers got it, they just could see something, read it, and just implement it. We also abstracted a lot of this stuff just into our own little libraries and had some documentation so they could npm install or pip install our own package, and they just kind of have everything straight away. So starting off, we stood our cluster up with the kube up script, and we just turned on the FluentD logging into Elasticsearch. This was working during testing, which was great. And then we upgraded to 1.3 and had kubedns and realized it was a lot more talkative than we thought it was going to be. And it just filled up our volume on one of our hosts and crashed a minion. So we were Kubernetes rookies. We weren't used to running stateful containers, and we didn't really know about what was going on there. So we just thought, you know what? Let's figure out something else. Let's not dig in on this. So we basically got rid of that. And we kind of wanted to figure out, played around with a couple different ideas on how to roll our own kind of way to get into an Elasticsearch cluster that we hosted externally, just on an EC2 instance, a couple EC2 instances. So, we wanted control. We used FluentD, so we tried a couple different approaches. And one approach that is fairly popular, you may have seen before, is the Besidecar approach, where your pod has two containers, your application container and your logging container, which is basically just FluentD listening and tailing a log on a shared volume. So your one container writes to a log, it gets shared into your FluentD container, and it gets piped out to wherever. We chose to just throw the logs right at Amazon Kinesis, and you can just hook in, point, kind of a couple clicks, point it right at an Elasticsearch cluster, an S3 backups, and it got us, we may be able to save money down the road if we choose other solutions, but right now it just got us off the ground and really has just improved our, taking that off our plate for right now. So that's been great. We don't regret that, and we'll probably stay with that for the considerable future as we grow. So some of the pros were that it was flexible and independent. Each pod could handle the load that it was seeing. So it wouldn't, there's no single point of failure, no dependency on a single service running in the cluster. Some of the cons were that, the application had to handle log rotation or something. There's still a lot of question marks on that of what would handle that. We also had more complex pod configurations that were just these big YAML files with secrets and volumes and stuff that were kind of making it more complex to reason about. Not too bad, but it was nice without them. And we're also running 2 times the containers, so if we were scaling, we scaled the service from 5 to 50 at one point as we were scaling it up, and it's running a lot more containers. This just kind of felt like we were using excessive resources to do stuff. So, we tried off with another approach, which is pretty much inspired by the kind of FluentD logging that comes with everything. We used a daemon set to run FluentD on each machine and tail the container logs. And it was great. We used a little bit more resources, but for that pod. But overall, with the reducing the number of containers, it was a lot more efficient for us. And it was also one way, if we wanted to roll out an update to this thing, it was one place to roll it instead of updating each one of our application pod configurations. Because we didn't want to have to do that after we're running hundreds of pods on our instance. So these are just some of the things we were trying to look ahead to, and we also wanted to add more flexibility and not just have everyone logged standard out. So we just we opened up a TCP port and used the TCP plugin on FluentD and just allowed our devs to pipe their logs straight via that if they couldn't log to standard out. In our standard libraries that we have in the company, you can just flip a Boolean and then you're going to TCP instead of standard out. So we wanted to make it dead simple for people. We're still using Kinesis as our transport kind of layer. So this has been super reliable, has scaled as we've scaled up services. So, this has been pretty nice and given us a lot of control with some of these things. We're also able to listen to other logs that are structured of using FluentD to say you send different logs to different Kinesis streams. So that's something that we've experimented with for internal user behavior metrics instead of just logging data. So that's been really great to just customize FluentD, which has been awesome. So yeah, I highly recommend this kind of approach, rolling your own kind of daemon set. That moves us on to monitoring alerts. This is kind of a quick little slide, but Kubernetes was allowing us to set resource limits on all our containers and everything, which was awesome. But if we didn't know how our containers were running, then what good are the resource limits? So we wanted developers to love building new services and easier to monitor anything and create alerts around their own thing. They were the developers that created the app. We wanted them to be able to easily add these things and control their kind of applications. So started with Prometheus, clear starting point, great, awesome project. But we wanted people who had no experience with any of this stuff to be able to add things. So we said, let's look for something, a little bit easier, a little bit more straightforward. For the average kind of, say, even a front-end developer can be, creating alerts and tracking everything. So we started then also throwing application metrics in our logs, and we started creating dashboards in Kibana, which was great, but then we wanted to trigger alerts, so we tried to use a project called ElastAlert, and that was, again, a little bit more complex than we wanted to. So, and we had 2 different locations for all this information. So in the end, we ended up checking out Datadog, and it was pretty awesome, and of course it has a cost, but this is one of those trade-offs that we made of saying this, was so much easier for our team, and we really just wanted, at this point, to get just adoption for all our engineers, make things like a breeze to work on and collaborate on. So it's been awesome, leveraging all their integrations and DogStatsD library to pipe all your custom metrics right into Datadog. This has been awesome, really developer friendly, exactly what we needed right now to kind of push us forward. And our monitoring overall has been leaps and bounds, just better than whatever we had before. We're creating some off-the-shelf dashboards for people to use, so it's been fantastic to see the adoption. We kind of going from there. We started creating some internal best practices. There's a lot of ways that you can use Kubernetes. We needed to figure out how we're going to do this, how we're going to do that. Kind of some standardized things, pave the way for the developers, reduce the complexity for them to build new services. And reduce the number of choices that they really need to make. Just kind of pave the way for them, but give them a little bit of flexibility. We standardize various bits, also help us to create standard tooling if everything's happening the same way. So that has really helped for us, especially with our deploy bot and everything, and some of the things that it does. We also wanted the standard things because if a teammate's asleep, which in our company happens a lot, and something goes off, someone needs to know how to reason about how to jump into something pretty quick. So standardization is really great. It's something that we didn't do as well in the early days because we were just moving fast, but this has been super key for us, as you probably can imagine. So we went through figuring out how do we want to use Kubernetes labels. We used them a bunch of different ways, and kind of just kick the tires and everything, and we're able to figure out some standard labels that we want to use, and paving the way for canary deploys and everything, for our internal services and everything. So, yeah, it's been great. Just making it dead simple to kind of setting up our different tracks and being able to do these things from the day one of every service is awesome. So when some developer says I want to do this, but I want to do a canary, it's already there for them. So we've kind of standardized a lot of these things and started standardizing our monitoring metrics and everything. And we've taken a little page out of Kubernetes books and started our own internal special interest group for our monitoring. So we have a couple people who are kind of a clone of Kubernetes special interest groups, and hoping they will push forward the agenda and moving this, continuing on, as we grow and have different types of complex services that we're running. So we're going to have this cross-disciplinary. There's going to be DevOps or systems type engineers and product engineers that, to kind of be able to guide this moving forward. We're not finished with this part yet, but we're always going to be continuously evolving. But to start, this has been really a boon for our developers. So one other thing that we wanted to do is figure out what our guinea pig was. We call this an exemplar. It's the work for Kubernetes is good, but it's only great if it's actually put to use. So inspired by a great book called Building Microservices by Sam Newman, we set off to build an exemplar. If you're unfamiliar with this term, you have the classic definition. A person or thing serves as an excellent model, worthy of imitation. Or to kind of paraphrase Sam Newman in the book, a real-world service that implements your best standards and practices that you'd like to encourage in future services built by your team. We had to create one of these things, basically. It was what we needed to do. So to do this, we needed several goals. It had to be a real production service. You needed to really demonstrate to engineers and everything that it could handle real traffic, and this is how something was really going to work in the real world. It was important that it handled a solid amount of production traffic. It wasn't just something trivial that got hit 5 times a day. So we chose something that was fairly crucial to our service, but had a very defined scope. So this will serve as living documentation of all our best practices, basically. People will look to this service and say, oh, well, I can look to here and see how we actually did X, Y, and Z. There's also a model from which other services are built, so spend the time to get it right. These have been extra powerful because they're also concepts and applications and services that your team understands already. This was something that was a core. The couple that we built were core aspects of our architecture that we knew that everyone knew how this worked and could understand and reason about the code. So having perfect examples or demo repos are great, but they're created in pristine conditions, and they may not be relatable to actual services on your team. So I'm sure you've seen documentation say, oh, that looks perfect, it's in this idyllic world, but it doesn't actually work for my thing, so you have to figure out that. So these are things that I highly recommend. They've been really helpful to pave the way for people and show how we can build services. And also lastly, this really allowed us to kick the tires on Kubernetes, building something that we knew how much traffic it would have to serve. We were able to experiment with things on our team for the first time, that we were learning Kubernetes, resource limits and auto scaling, rollouts, rollbacks, canary deploys. We could also use the existing services throughput that it was seeing for our existing kind of legacy monitoring stuff, so we could throw real production traffic at it before it even received real production traffic. So we could simulate that and actually trust our Kubernetes cluster. We were standing this thing up for the first time. We just really needed to trust this thing. So this really helped. Started out with one kind of exemplar on our team. We found that it was useful to have different kind of exemplars for different types of services, whether they be a web server or a worker consuming off a message queue. It was really helpful to kind of push our team forward and really figure out everything with Kubernetes. So yeah, after our plan, where does that bring us to today? We spent, the summer experimenting, the last 2-3 months really working with Kubernetes and pushing services there, mostly since beginning of September. We're super stoked with all the progress that we've made. We probably have about 5 teams that are running just 26 deployments, so it still feels, to some of you this is small numbers, but for our team, we're super pumped about this, and we're kind of have user-facing services, data pipelines, data analysis jobs, internal services. It's been amazing. We needed an internal service the other day, and something got deleted incorrectly off a server that wasn't in version control. So we just built a new service, deployed it, and were able to get it out in under an hour. So it was writing it from scratch and seeing it into production it was just unbelievable. It's been so powerful. I'd say that this is kind of arbitrary, but we've had 10 times more insight into our running applications than we've ever had before with the logging and monitoring and everything. Our resource limits and really seeing how many crashes or restarts that our applications have. we rolled out a new service yesterday, actually, and now we took 50. Now we're over 50% of our traffic is going through our Kubernetes cluster, which is a major milestone for us. We just hit over 54%. So we've been able to start scaling down our old infrastructure now, which is exactly what we wanted to do, start shifting things away. So that was a major kind of milestone for us that we're super stoked about. And although it was a little bit bumpy, I had to address some things, some issues, some backlogs with kubedns about 40 minutes ago. So it's still a learning experience, but it's been pretty fun. And we've really reached our goal of allowing our teams around the world to deploy new services and be highly independent of each other. Not really have to feel like it's a huge process and you have to file something and plan something days ahead of time. We're getting things out so much faster than we ever have. We're continuously shipping new versions at all hours of the day. And our application is not tightly coupled anymore. These things are independent and we have alerting on everything. So these independent services are not bringing down our entire infrastructure. It's really great not having to coordinate with and lean on DevOps people that are all the way around the world. That's been incredible to really free us up. So what's next for Buffer and Kubernetes? We're still Kubernetes rookies. Like there's still a lot more for us to do. We still have a lot of challenges that I'm sure are pretty common with a lot of you out there. We really need to improve the development to production story about how do we get Docker Compose or a regular Docker file into production and connect the right services. And so that's definitely something that we really want to improve that flow for our developers. We're still like, it's at a weird point. We're pushing there and we're trying to make it better. Hoping to build some new tooling around everything. So we're not sure if that really means better documentation, tooling, training, but we're also seeing how our actual developers, our product engineers are doing these things and what creative solutions they're coming up with and feeding that back in. So that's been pretty fun. We're also really exploring things like COPS for cluster upgrades and kind of rolling out new clusters, spinning things up. Like I said, we really need to get better at that. That's still a bit of a challenge for us. We're hoping to get to the point where our clusters are feel like they're disposable, and we're not scared about upgrading. We're not scared about running two at once and seeing where everything goes. We're also we want to get better with our resource configuration and deploys. That it's kind of awkward also how we have everything set up. Like it works, but it's not great. So we're really excited about things like Helm, and we think that it could really be much easier to reason about and how we manage our configurations and deployments and everything. So we're really excited about stuff like that. And lastly, I think even previous speaker talked about security in between pods, and there is none. We don't have any, and we are encrypting things as we send them through, but we are not running it on TLS. So having things like Linkerd or whatever are really things that we're at that stage of experimenting with and kind of figuring out what's the best solution for us. So that's a little bit of an unknown territory for us, but we're really excited about. And we're also, like I said earlier, we're creating these special interest groups that have actually been really fun ways to kind of pull these things together and create new teams that are, not just DevOps, they're cross-disciplinary teams that are really pushing these things. And after this, overall, Kubernetes just has feeling like Swayze cleaned everything up. And not to give away the end of the movie, but Swayze came up and he cleaned everything. You see how they're in top shape now. And Kubernetes really showed us how to clean up our infrastructure and gave us some really great things that have dramatically improved the way we build services. I hope I gave you a little bit of insight into how our small team of kind of containers and Kubernetes rookies we're able to push things into production and just improve our infrastructure dramatically. So I'd just love to hear any questions that you might have or anything at all, any feedback or anything, but I appreciate it. Yeah?
Love Roadhouse. Perfect.
Thank you. Anyone else have anything? Yeah?
Do you have automated undeploy? If something's screwed up, does an engineer have to go in
No, we have that slash command, so it's slash deploy rollback my service. So that will automatically undo the deployment, so they don't need to go to use kubectl to do anything.
That's still manually. You have to manually
Yeah. Right. So that will use the bot to use kubectl to roll out undo. So yeah, we don't have any automated like continuous delivery like rollbacks or anything. That's something that we'll hopefully experiment with a little bit based on whatever metric we need, quality metrics. So yeah, that's where we're at with that. Anyone in the back?
What do you use for load balancing?
For load balancing, we are using Elastic Load Balancer because we're running on AWS. So we're building our, we're using our just load balancer services, and that'll spin up our load balancer. So we're using that. We're pretty happy with it for now. Yeah. Down here.
How many devs did you have to train? You got to have this SWAT team that hit you first or whatever. And then I'm worried about the politics. We're about to go through the same transition. I was just curious about how you had that knowledge spread throughout the team, how you got buy-in. Were there any politics in general?
Yeah. So that's tough because I think there were also even some people that were not in engineering, say like in the high level, they were like, what is this project that you're working on and why is it valuable? Because they were saying that we're going to lose, say time on redoing our infrastructure when we could be shipping more product or something like that. So there's definitely a bit of trust at the beginning half, and the training side of it, that's mostly been on a one-on-one basis. We've handpicked kind of some engineers that have some projects and maybe the know-how to say like, okay, you want to and you have the ability to move this out. Some people who are like really will get in the weeds with these things and move their services into the clusters. So it's kind of been piecemeal right now. It's pretty slow. We're going to start doing some more this quarter. We're going to start doing some more actual like recorded video training because we're all remote, so it's like kind of difficult to do that. So there's a lot of ad hoc training one-on-one on video about how to get service out and everything. So it's a lot of documentation, and we're hoping that as we slowly spread this out and get just a few engineers on board, we'll see like a domino effect. Those engineers will train others, and we'll continue to build the kind of documentation and everything. So luckily our team is not gigantic, so it's a little bit easier to do for us, but definitely sharing that knowledge asynchronously is a bit of a challenge. So yeah, I don't know if I exactly like answered that, but yeah, it's not the easiest, but yeah, more training and and really showing people the ropes has helped. And then a lot of the abstractions has kind of reduced some of the complexities, so someone might not have to think about why labels are important straight away. If they want to dig in, they can. But from the beginning, like abstracting some of these things away and just giving them things kind of on like a platter, like giving them a how-to has kind of helped at least make that leap. And then each they can dig in a layer deeper in kind of all the aspects, if that makes sense. Yeah, over here.
More incidents in downtime or less?
We have had some incidents in downtime.
More than before or less?
More. I'd say we've had like unforeseen things that we didn't know. We were novice at Kubernetes. So I'd say overall, individual services have been more reliable and just kind of the growing pains of getting used to Kubernetes. So I'd say overall, it's been extremely reliable. So I'd say it's more reliable than what we had before, but it's tough to compare like the monolith versus all like little different pieces that have different kind of their own kind of metrics. So I'd say, yeah, overall, like it's been better, been more reliable, more set it and forget it for services. Over here.
Are there some parts of Offer that you've never switched to Kubernetes?
I don't, yeah.
Databases?
Yeah, I think we're since we're so early on in that bit, running stateful stuff, especially with the Elasticsearch example, we have decided, not yet until, like we also need to understand, say, pet sets a little bit more. So we want to do that, but we want to experiment with some non-crucial things that are not totally essential, like say logging or certain things that are just internal services that can fail, that we can, not rely for stuff right away. Still, right now, all of our databases are actually hosted databases. We don't host any of our own stuff. So that's just a decision that we made. So that's something we like to do, but not yet. Yeah. Anyone else? Anyone else? All right, well, thank you guys. I really appreciate everyone listening, and feel free to contact me or pull me aside and ask any questions. All right, thanks. Have a great lunch.